Dear all, welcome to this new episode of the CATIA TV, this time on how to model and simulate on the platform using the MODSIM approach. In the recent years, the merge of modeling and simulation, MODSIM, has drastically improved in order to create products that are more complex, but at the same time, with reduced life cycles and with innovative materials and systems that will enhance the final user experience. In this context, CATIA, the mod, and Simulia, the sim, are at the forefront of innovation in this new global MODSIM approach. In this webinar, you will discover how two professionals are to design and simulate on the platform, thanks to our two subject matter experts, Romil Tainov, Simulia Industry Business Consultant Expert, and Rohit Bhardwaj, CATIA Industry Consultant Expert, who will show you collaboration, simulation, and design concurrently using the 3D Experience platform. So welcome to this new episode of the CATIA TV, and remember that you can always ask your questions in this post in the CATIA community. We wish you a very good webinar and a very good day.
Hi, my name is Rohit Bhardwaj. I'm with CATIA brand team in North America. Today I have my friend Romil with me. Romil?
Hi, my name is Romil Tainov. I'm a structural engineer and a technical expert with the Simulia brand of the Sausage Stuffs.
Okay, good. Today we'll do a short session on how it is to work together on the 3D Experience platform. So in the age of COVID-19, we are all stuck at home, and it might be really useful to see how people do product development concurrently on 3D Experience platform. So this is going to be the topic for today, the 3D Experience collaborative environment for CATIA and Simulia. Today, typically when we talk to the customers, this is what we generally see. They are using different point solutions. Sometimes these solutions are bandaged together with a PDM. Within product development, CAD, CAM, CAE, teams use different electronic tools requiring translation of data. And every time the data has to be exchanged, it needs to be converted to a neutral format. The typical work in progress seems like a never-ending process of check-in, check-outs, managing revisions, and having to reconcile the most updated assembly. This is not fun, and there is a potential for a lot of mistakes. Every time a person makes a save, there's a potential of mistakes because somebody else who is using the same data doesn't really know which is the most updated and current version they need to consume downstream. And if we take it to the next step, if we want to run some sort of an iterative simulation loop to optimize the design and run simulation cycle, the neutral files make it really hard for us to access parameters, and it becomes really impossible to run design simulation loops. The net result is that the experimentation takes a very long time. These siloed operations create a lot of friction, and the PDMs which are managing files, they keep on adding more and more overhead on the engineering teams, resulting in about 30% of the time being totally non-productive, and people having to talk to each other, make mistakes, having to redo the work. Sometimes these lead to a lot of costly errors. So the main topic for today is collaboration. So there are unique possibilities of collaboration which are brought together by the 3D Experience platform. The first one is a social collaboration. So social collaboration connects different departments, engineers, simulation people, even sales and marketing teams. They can come together on a social platform in communities. They can exchange ideas, they can do intelligent dashboarding, they can even do project reviews, discuss different ideas to work on, and have a collaborative environment where they are doing kind of a non-product or non-program related discussion if they want to. The third one, I'll say the third one first. The third one is more of a structured collaboration where the platform provides a way to securely do data exchange, data sharing where the platform manages the versioning, the revisioning, traceability, lifecycle, and and it it helps everybody to track what is actually going on. The second layer is what we are going to mostly cover. People don't really talk enough about it. It's kind of work in progress, collaborative development layer where people are connected real time to the 3D experience platform, and different people, designers, engineers, simulation people, they're all working to the same data at the same time. So this is the main focus of today's session. What we're going to show are 4 different scenarios where we'll see 2 designers who are working concurrently, how that works out. Then what we'll do is we'll have a designer and an analyst work together. This is where my friend Romil is going to come in, and we'll do a collaborative design and simulation session. The third one is kind of a review, kind of post design meeting that we can enable on the platform. And then we may, if there's time, we can quickly talk about how the platform opens up the possibilities of running different iterative cycles. So let's quickly jump into the first scenario. What you see on my screen, I've divided my screen in 2. You can see 2 different sessions. One is kind of team leader. He's working on multiple parts in the assembly. The other screen that you see on the right is a designer. He may be responsible for one part out of the whole assembly. So the person so the person on the right has not logged in yet on the platform, whereas the person on the left, he started design work. He's assembling different parts in the assembly. Here you see him adding constraints to pins. Now there could be, a lot of different people working on a lot of different parts and sub-assemblies on different time zones. And it becomes a big nightmare when we have to make them work together. What you will see is a really smooth and easy, informal way to work together on the platform. So we can imagine the designer on the right is still sleeping in a different time zone, and he's going to come online very soon. So the guy on the left is working on the assembly. Okay, he has added constraints. And so finally, the design on the right shows up. What he can do is he can look at a part that he wants to work on, and he can quickly go in and lock that part. So what he's really locking is a lock on the shape of that part or the form of that part. And the team leader on the left still has the control over the fit or the placement of that part. So you can see that these 2 guys can keep working together. He's still, changing positions, adding constraints. Okay. And very soon what you will see is that the designer will start editing this part. Okay. So now that he has logged it, he can just go on and open the part. Once this part is active, he can then start authoring different things, maybe, just add few features like fillets. Okay, so once he has done his changes, and he can do a file save. The guy on the left, he may or may not, depending on how we set up the notifications. What he can just go and do is he can go and do a PLM refresh. And PLM refresh is going to trigger all the saves that everybody else in the team has done. Maybe, there are 7 things changed, different people working. And the moment he does a session refresh, you can see that the latest geometry of the pin gets refreshed in his session. So what we are seeing is that he doesn't even have to close his session, find what is the latest part, reconcile it in the assembly. But you can see he can still keep going. The designer on the left, on the right, he has finished his part. He can then just go and unlock uh, his lock and close his session. Right. So it's very transparent. It's very flexible, and this is what the data-driven environment feels like. Imagine the same scenario if we have to do the same scenario with a traditional PDM file-based system. You would have people sending emails, hey, I want to check, I want to, edit this part. Let me check out this file. And then once he checks out the file, the other guy has stopped his session. Now he has to wait for the other guy because he's working on the other on that part. We can actually compare the whole system to an airline check-in boarding pass system. 10 years ago, we started doing online check-ins. And what we would get is a PDF of a boarding pass in our email, right? So once we have the static file, this PDF file, we never know when it's out of date. We never know if the flight has been delayed, if there's a gate change or anything like that. But now with the data-driven apps on the phone, we have a wallet with the digital boarding pass. If there's a change, update in the boarding gate, delay in the flights, our boarding pass updates. There is no chance for us to miss our flights. There's kind of no excuse now to miss our flights. So on the 3D Experience platform, it is the same data-driven experience that you get, and not really, sending files back and forth. So what that impacts is the overall cycle time that we end up having to incur in a program, where you would have either multiple people checking in, checking out files, and then the product manager having to reconcile different versions, releases from different people. Whereas kind of for the work in the progress session on the platform, it's very, very transparent, and everything refreshes in session. Okay. So I'll quickly show you the next scenario, how two people work together on the platform. So now imagine that there are two designers. One designer is working on the holder part. The other person is designing the head strap of this face shield. What they can do is within CATIA, they can enable a live chat session. So he can just start chatting with the other guy. Hey, what's up? What are you doing today? I need help with certain, features. So you can see the guy on the left, he wants to design something complementary feature. For example, there is a hole in the strap which needs to match the holes in the head in this band. Right. So he can say, what are you working on? The moment he accepts it, he can see in a ghost view what is the context of what the other guy is working with right now. Right. And then he can say, hey, you've already done that holes. Can you please share these holes with me? Okay, so the guy on the right, he selects the hole and clicks on a design share. The moment he accepts the holes start appearing in his model. Okay, so what we've seen is people throwing features back and forth like chat attachments. So for this level of collaboration, they don't have to save their file, send the file over. The other guy tries to extract some portion from the file. It's all that work is gone. They can just start throwing features back and forth between two of them. Now you see that this guy has received the holes. He doesn't need to worry about the location and everything. That's all done. He can just then go on and assemble the holes in his file. The guy on the right, he then starts saying, hey, have you done the reference curves? Can you throw some curves to me? Right. So imagine that we're all working from home in a COVID-19, in the age of COVID-19, and people working so transparently between their sessions. So once the guy on the right accepts, the curves start appearing in his session. So the same thing if we were to do on a traditional system, the designer on the right would have had to send an email. Hey, I want to speak to you. What is the best time for a meeting? I want to show you what I really need. Right? Set up a WebEx meeting. That takes a while, and then exactly sharing the right amount, the right data with the guy on the left. That would have taken maybe half a day just to share the right information between two people working on the same team. What we see now is a similar collaborative scenario with the simulation. I think Romel is the analyst in this example. Romel, can you start talking about the simulation and design scenario, please?
Sure. So based on the CAD that Rohit has prepared, I have made a simulation of putting that headband on the head, and I am interested in what the contact pressure is between the band and the head. So what we're seeing is the assembled and tightened headband. What we are looking at is the contact pressure here, and I see that we have some high pressure points at the forehead. I think the area of contact is too small. If we increase that area, we'll probably reduce the contact pressure. So I'm looking at the designer for the CAD designer for the project, and I'm trying to chat with him and ask him if he can change the geometry so we have we decrease the contact pressure. So I am pinging Rohit. It looks like he got my message and he's responding. So I will ask him to increase the length of the contact portion of the band with the forehead. In this case, it's a simple parameter, length parameter, but it can be a very complex CAD feature, which the designer needs to change. So Rohit has received my request. He will go ahead and make the change. I will wait for him to acknowledge the change, and then I will refresh my model and rerun the simulation.
So here you see that the designer got a request to, hey, can you try out bigger lengths? And he's trying out few lengths. And the designer thinks 25 is what will work. Right, so they have a quick discussion if that is okay.
So looks like he's already done the changes. Now I need to propagate this in my model.
Yeah. So once the change is agreed upon, the designer can just save, right?
So here I am propagating the cut changes, and then I will refresh my finite element model.
So the analyst doesn't even have to worry about if he has sent the change over or not. He just has to click on refresh, right?
Yep. And now we switch from results viewing into the model, and we can see that the cat has updated, but the mesh is still the old mesh. Now I need to refresh, update the mesh to comply with the new geometry. And now my finite element model is ready. I can resubmit and get the new results.
Yeah, if we compare it to a traditional scenario where design has to, check in a new version of the design, and then simulation people have to verify if that is the right change that they requested, and just the logistics of getting this small thing done is a big nightmare. So what you see on the screen is the designer continues to work. He keeps on making his changes. He's still working on the face shield, and he decides to decrease or change the length of the face shield. Right, whatever he decides, okay, this is going to be the length. He uh, saves his session and tells the simulation guy, hey, I've done these changes. This could be an automated notification, by the way, as well. In this scenario, because we are just showing collaboration, he can just go in, log into the chat, and talk to the simulation. Hey, I've made these changes. You may want to recompute. Can quickly skip the video to the step where he starts talking to the analyst again. So this is all live, concurrent, people working together on the same project at the same time. It's we are really shortening the waterfall model of project. People waiting for milestones to get going. Here you see two guys can just chat and say, hey, I've updated, just refresh your session. That's it. And that's all it takes.
So the designer is informing me that he has changed the geometry of the shield itself. This is a different simulation that I've previously performed. So it looks like I will have to go and do the same thing. I will have to update the cat, update my finite element mesh, and rerun that simulation to make sure the forming of the shield is fine. So I'm opening the face shield simulation now.
So there could be multiple simulation objects connected to the same CAD data, right? If one changes, all the different test cases change as well.
We currently have 2 finite element models connected to the same CAD data and 2 simulations using each of those finite element models. Now I can see the shield finite element mesh. I will show the shield CAD also.
So to propagate changes again, they just need to refresh their session. Can go in, click on PLM refresh, and the most updated geometry is gonna load within the same session. Yes, refresh session and run an update.
So I'm refreshing the CAD and updating the finite element mesh. And now you'll see the mesh change to conform to the new shape. And the simulation starts with the initial flat shape and then simulates how the shield is being formed into shape.
Yeah.
Now it's ready to rerun the simulation again.
Yeah, so it's it's that easy. If you compare it to a traditional PDM where it's all check-ins, checkouts, and having to reconcile these and recreate the simulation model, we can just compute the delta that we have changed and recompute and then update the simulation results. Another small video that I want to show is, so we've just seen a simple collaborative scenario. Now there could be a little bit more serious changes where the two teams, they may want to discuss an issue, right? It may not just be, hey, can you change one length parameter, right? So what you see right now happening is a designer and an analyst, they're still working and they want to start doing a co-review session, right? So they want to discuss something serious, and once the analyst accepts the co-review, he can start seeing the data that designer wants him to see. Okay, so the co-review session is coming up. What you can see is they want to talk about this headband. The guy on the left is actually driving the session. When he zooms on a part, the screen of the guy on the right changes, the viewpoint matches. The other thing that you can note is they don't have the exact same view. So the guy on the left may have a different security context and he may have 20 different things that he's working on. But the guy on the right, he only has a security clearance to view certain parts, right? So he doesn't see the full session. but he only sees the parts that he has access to. Now they can do markups, they can zoom, pan, highlight certain issues, and do a review session. In the middle of the session, the guy on the right, he may want to take control, and he says, okay, let me show you some things that are pending on your side. Now what you see is the guy on the right, he will say, I'm going to lead the review session right now. Designer accepts. The moment he accepts, you can see that the analyst is now leading the session, and he'll start highlighting the issues. There are no fillets on these things. These things might crack, right? So they're discussing issues, they're doing markups, and they're sharing screens, all the three things at the same time. What we can also enable is a video chat running within CATIA session as well, audio and video. It just doesn't have to be a simple plain text chat. So he's highlighting where he wants fillets, and designer knows exactly what he means, right? If it was, screenshots sent on email, there may be certain things that might be missing, right? So they're talking about different areas to review and change. And what happens in the end is once the session is done, so they're still talking about different things. Hey, I don't need this. I need a change here. I need a change there. What will happen in the end is once they've done this review session, they can have a record of this co-review session, right? He can click on this email icon, and it makes all the minutes of meetings, all the annotations, snapshots that they took. They were all recorded as attachments of the email, and they can also, then CC other people. Hey, this is what we talked about. This is what we decided, and we are going to make this change, right? So it's not just an informal chat anymore. If they want to formalize it, inform other people, then they can go ahead and do that as well. So just by doing this, sometimes we avoid days and days of doing, design to manufacturability reviews meetings or simulation review meetings, and people trying to book a room, block everybody's time when practically what happens is only 20% of the people are actually required for those meetings. Others are there just to listen in. So we avoid a lot of this non-productive, wasteful meetings by just doing informal co-review sessions on the platform. Romil, do you have anything to add on this?
Well, this is a great example of collaboration between analyst and designer, showing how we can share the same data, work on the same data at the same time, and speed up the performance simulation.
So I'll conclude the session with overall summary and benefits that we've seen. So 3 experiences for design and simulation. It is the exact same environment for design and simulation with complete associativity back and forth. It is seamlessly integrated. There is no files, check-in, checkouts, like a traditional PDM. Anytime there's a change in design, it is automatically updated in simulation. It is the way and there are different levels to which we can control to make it completely seamless or make it interactive as well, and have it manually change as well. And it enables a lot of iterations, design, experimentations, and simulations that we can do, and reduces the wasteful workload for the engineers. So that's about all that that I have to show you today.
you.